When it comes to space, we've been told countless fascinating facts. But what if I told you that many of them are oversimplified, misunderstood, or just plain wrong? From the true nature of black holes to the real shape of our galaxy, let's dive into the misconceptions about space that will leave you questioning everything you thought you knew. Ready? Let's get started. We often hear that space is a vast, empty vacuum. But here's the truth. Space is far from empty. Between stars and galaxies lies the interstellar medium, filled with gas, dust, and even mysterious particles like neutrinos that constantly pass through us. In fact, even the emptiest regions of space have about one atom per cubic centimeter. Not much, but it's something. And then there's dark matter, an invisible substance we can't see or touch, making up 85% of the universe's mass. Space isn't just empty, it's teeming with mysteries. You've probably heard people say the sun is on fire, but that's not true. Fire, as we know it, requires oxygen, and there's none in space. The sun isn't burning, it's undergoing nuclear fusion. In its core, hydrogen atoms collide and fuse into helium, releasing enormous amounts of energy. This process powers the sun and creates the light and heat we rely on. So next time someone says the sun is a giant ball of fire, feel free to set the record straight. Ever seen those textbook images of Earth as a perfect sphere? Well, they're wrong. Earth is actually an oblate spheroid, meaning it's slightly squished at the poles and bulging at the equator. This happens because of Earth's rotation, which causes centrifugal force to push outward at the equator. The difference isn't huge, just about 42 kilometers, but it's enough to make Earth more of a cosmic pancake than a perfect ball. Black holes have a terrifying reputation as cosmic vacuum cleaners that suck in everything around them. But here's the truth. Black holes don't suck. A black hole's gravity works just like any other object's gravity. It pulls things toward it, but only if they're close enough. Objects farther away simply orbit the black hole, just like the planets orbit the sun. In fact, if our sun were replaced by a black hole of the same mass, Earth would keep orbiting it, unaffected, except we'd freeze to death without sunlight. Here's a common phrase you probably heard. Astronauts experience zero gravity in space. But that's not entirely accurate. Gravity exists everywhere in the universe. It's what holds the moon in orbit around Earth and keeps the ISS circling our planet. Astronauts float because they're in free fall. The ISS is constantly falling toward Earth, but it's moving so fast sideways that it keeps missing the planet, creating the sensation of weightlessness. So it's not zero gravity, it's more like falling forever. Another myth about space? The moon has a dark side. The truth is, the far side of the moon gets just as much sunlight as the side facing us. What's actually happening is tidal locking. The moon's rotation is synchronized with its orbit around Earth, so we only see one side. The far side is hidden, but it's not perpetually dark. It has days and nights, just like the near side. Textbooks and posters often show the Milky Way as a perfect spiral, but the reality is much messier. For one, the Milky Way is a barred spiral galaxy, meaning it has a bar-shaped core of stars at its center. Even stranger? The Milky Way's edges are warped, likely due to gravitational interactions with neighboring galaxies. So while it's still beautiful, our galaxy isn't the neat, symmetrical spiral you might imagine. We think of light as the ultimate traveler, able to move endlessly through the universe. But in reality, light can be absorbed or scattered by interstellar dust and gas. Even in the emptiest parts of space, photons lose energy over time due to the expansion of the universe, a phenomenon known as redshift. So while light can travel incredible distances, it doesn't last forever. Twinkle, twinkle, little star, we've all sung it, but stars don't actually twinkle. The twinkling effect, called stellar scintillation, is caused by Earth's atmosphere. As starlight passes through layers of air with varying temperatures and densities, it bends and shifts, creating the illusion of twinkling. If you were in space, away from Earth's atmosphere, stars would appear steady, like tiny, unblinking points of light. Venus is often called Earth's twin because of its similar size and composition, but the similarities end there. Venus has a surface temperature hot enough to melt lead thanks to a runaway greenhouse effect. Its atmosphere is made mostly of carbon dioxide, with clouds of sulfuric acid. If anything, Venus is more like a cautionary tale of what could happen to Earth under extreme conditions. We think of space as silent because sound needs a medium like air to travel, but space has its own sounds in the form of electromagnetic vibrations. NASA has even recorded these signals and converted them into audio, revealing eerie songs of planets and stars. While you can't hear sound waves in the vacuum of space, it's fascinating to know the universe is still humming with activity. Space is more incredible and more complex than we often realize. By questioning what we think we know, we unlock a deeper understanding of the universe and our place within it. If you found these truths mind-blowing, don't forget to like, share, and subscribe. There's so much more to explore together, so stay curious, and I'll see you next time.